Using Piezoelectricity to Design Self-Sustaining Homes by Mina Comaretti, Jessie Chase, Luc DeBlock, and Enzo van der Krol. According to NASA, carbon dioxide from human activity is increasing more than 250 times faster than it did from natural sources after the last ice age. Burning fossil fuels for electricity causes extensive damage to the environment. Reduction of fossil fuel pollution can be possible using renewable and sustainable energy sources like piezoelectricity. This is created by the application of pressure on certain materials to create an electric charge. To test which piezoelectric element worked better to generate electricity, our group tested 4 different materials. Our results showed that our method was insufficient, but with more time and better testing method, we are confident that piezoelectricity can be a great, sustainable way to generate future electricity. To test the piezoelectricity, we created 4 different inserts, one with sugar and one with quartz, and then the last 2 were created using piezoelectric discs. For all the prototypes on a breadboard, we built a diode rectifier bridge. After it was built, we hooked up each piezoelectric material to the breadboard. Then we inserted the capacitor and the LED. To measure the electricity generated, we used alligator clips to clip the positive lead of the capacitor and the other end of the alligator clip to connect it to the red lead on the multimeter. We repeated the same process for the negative lead of the capacitor. Then we tested by tapping the materials and measuring the output of electricity. The results of our experiment proved that in prototype 1, the sugar produced a small current that the multimeter couldn't pick up. Quartz was able to generate 1 volt of energy after tapping it 200 times and was able to reach 2 volts of energy after tapping it 275 times. The prototypes with 1 piezo disc produced 2 volts after 100 and 109 taps respectively. In order to try and produce more voltage, we made a prototype with 4 discs. This time after 100 taps, we were able to produce 4.1 volts of energy. The picture below shows the prototype with 4 discs, and the graph above shows a direct comparison of the different prototypes and the different elements.
After multiple tests, we concluded that quartz, our hypothesized most efficient material, was not the best. Instead, it was the setup with 4 piezoelectric discs. Although some of our tests were successful, the prototypes were of no practical use, with the most efficient design producing only about 4 volts after 100 taps. As modern household appliances such as light bulbs and phone chargers require 5 and 110 volts respectively, these designs are no realistic use. Even though our research did not produce any sustainable form of piezoelectric energy, it did open up ideas for future research. This may include implementing designs into flooring for higher voltage, or testing a wider variety of materials.
I am Luc DeBlock, and I will be covering the conclusion of our paper. Considering all our results, in the end, our goal of creating a prototype to help power households was not met. Even with higher amounts of pressure, there was not enough power created to be significant in powering a home. At the moment, piezoelectricity is on too small a scale to provide a larger impact, but it does warrant more research. In a world where power demand is very high and the main sources are destroying the planet, a sustainable way to create energy is something that is much needed. All in all, our goal of creating a prototype that could be used throughout a house to help provide power to the household appliances was not met. We learned that with current knowledge and technology, piezoelectricity is not a viable option for large-scale projects. With a decent amount of pressure applied, the volts produced simply was not enough. Using an install design with piezoelectricity may be a worthwhile test for the future, but still might not be enough for large-scale uses. Even so, as the use of unsustainable sources for power continues, piezoelectricity should be strongly considered and studied. Now and in the future, clean power sources are as valuable as ever. With further development and research, we hope that piezoelectricity is incorporated into everyday life for a more sustainable future.